Hey, I'm Shiang, and I'm building QuantomOS, not with one, but two PhDs, four patents, and being the world experts in this space, over 2,000 citations. So here's a problem, right? There's no AI compute budget in the world that's big enough to power compute, right? Everything we need. Wait, is it moving to? Did you click that? Okay, I didn't click that. But this is my next slide anyways. So the next slide is, there is a solution though. It's called quantum computing. But it's too few machines, it's too expensive, and you basically need a PhD to use it. Okay, I'm definitely not clicking, so is it just moved by itself? I did not. So sorry, one pause. Pause, you're interested, hold that interest. Ooh. No, I didn't set up any timer.
I'll hold the slide.
Like, it's going by itself.
Yeah, but if I'm here, like I can override it. Let's try that.
Oh, okay. Yeah, I'm good with either way.
You want second slide?
Second slide. Cool. All right, so there is something that exists now, and it's what we have the next slide. Cool, and it's QuantomOS. It is a bridge to actually utilize quantum computing today. You press one. No, is that your transition? Yeah, we just put all of them, it's fine. So let's go to the first slide. It's first a natural language interface, right? Just talk about the problem you want to optimize towards or that simulation you want to run. Second, this is where the magic happens. Here is where our patents lie, where we can break down a problem and utilize a hybrid solution, meaning utilize both classical and quantum computers in tandem without any degradation of accuracy. That's huge, right? And this last slide, this is just where we spit back the answer to you. Kind of like magic, right? And the last key point on this slide, same slide. This should be the last point here. Here it is. The key here, it saves 51% of compute time. Cut down any compute you have in half. Think how insane that is. Next slide. Cool. And our initial market here are actually hedge funds, right? Hedge funds have lots of optimizations to do daily. So you have 100 stocks in your portfolio. How do you want to rebalance that to make more money, right? There's optimization happening daily, but also constraints, right? Oil, weather, is there a war? And the cost of that, millions of dollars, right? $2 to $5 million per hedge fund because they have in-house quants and solutions they build that are bespoke to themselves. And we talked to over 30 hedge fund managers, and they all said the same thing. I wish I could run more simulations to make more money. And this is just the beginning, right? This is the AI compute market. This is almost a $1 trillion industry that's growing faster than we've ever seen. And just even an initial beachhead market of hedge funds, that's a $2 billion market. And of course, it's just the beginning, right? We start from hedge funds, go to investment banks, insurance, logistics, everyone has compute problems. And here's the thing, no one can do what we do unless you have a PhD and you can prove it. I think you can't do what we do. And we'll do the last slide here. And here's the thing, we're not just PhDs. We also are hustlers, business people, right? I myself started my career in Deloitte Consulting, it's my fourth company. And Akshit actually is a quantum researcher in the space at JP Morgan. Also, he was at previously a software company that actually sells software to hedge funds. So we know what we're doing. And if you have any questions, please reach out. And I promise you, the next part of my demo will be much more seamless. Not sure what's happening with the slide deck right now. Well, let me show you this demo. All right, so what does it look like, right? Let's actually see. Sign into our dashboard. Say you are a hedge fund manager now, right? You have a portfolio optimization. I just piece like this, ready for this demo here. Maybe you have a set of instruments. You have some sort of portfolio of X amount of size. You want to understand how to reach some sort of target. Let's see. Is doing things, understanding the problem, what's the best type of algorithm to run. Again, this is algorithm agnostic, right? This is a methodology, so you can use any algorithm that you like. And then it breaks it down. how can you understand this problem? Okay, also maybe we should add some more constraints, a little more to this optimization problem to make it more interesting, right? So we suggest that as well. As suggestion, okay, now let's understand how does this problem change with this new suggestion? We'll add in some thoughts here, and it's now regenerating that workflow. Now let's look at this workflow. You can see for every part of the workflow, what type of hardware it'll use. So is it classical, GPUs, quantum computing? You can see actually the cost, the algorithm that's going to run, and the estimated costs. And it breaks this all down for you. So it's super easy for you to use. And what's more important is you can see that at a nice log here, how much everything costs. So it's cost optimized too. So this does not cost any more than your current classical compute. That's the key. It's not more expensive. It's the same cost or lower and 50% faster. Think about that. And the cool thing here is everything is stored into workflow that you can just call via API to any new process you want to run. Cool. Now that's the end of the demo. Any questions? No, the agent is a commodity, right? It's just pulling any large language model. Correct. So that agent is imbued with our knowledge of utilizing this hybrid method of selecting the best algorithm for your particular problem. Sure. We're actually using quantum computers that we buy through like IBM. You guys should buy it like some like cloud credits, right? You guys should buy it now. Yeah, and then I show you in the last point, you can see the price live of buying a quantum credit. Depends. It depends on your problem. It's agnostic. In our research and with our customers, we've seen them run a variety of algorithms. It's not specific to one. There's a set of algorithms, correct. But I want to say you can kneel it down to, or you can't say just one or two algorithms are most utilized because it's always dependent on the client and what particular problem they want to optimize towards.